we got you. Wherever you want to from, we got what you need. Don't get online class, we got you.
Good day, everyone. Once again, you are welcome to Toydel online class. Just as I've introduced the set of numbers, so the first set of numbers, the first set of numbers are called the natural numbers. The natural numbers. So denoted, this one is denoted as n, as we have it on the bottom. Good day, viewers all over the world. You are welcome to Toydel online class. So today we want to look at a function of a function, which is otherwise known as chain rule. Is that it is called function of a function or chain rule? So is that you call it function of a function or chain rule? When I introduced differentiation, I said if y is a function of x, then the y dx, which is same thing as f prime of x, that simply means the first derivative. That's the first derivative. We can also have the square y all over dx squared, which is equal to f prime prime of x. That's the second derivative. So if y is a function of x, then the derivative is given as this, the first derivative, this second derivative. But under this concept, which is called function of a function, there are two things that is involved. If we have y to be the function of u, and u is a function of x, then the y dx will now be, the y dx will be dy du multiplied by du dx. Now let's look at, there are two functions here. Y is a function of u, while u is a function of x. So how do we get dy dx? Dy dx will be dy du. This is y dependent. In this case now, independent variable is u. So we take the right slight change in y over slight change in u, dy du. Then this second one is u is a function of x. So that will be du dx. Of course, how do we get our dx? The u can cancel the u here. Automatically, we are going to have dy over dx. So there are some questions that we cannot do directly. So we need to make some impression before we can actually get the value of dy dx. So in such case, our dy dx is equal to dy du multiplied by du ds. So this is also called chain rule or function of a function, because there are two functions here. U is a function of x, y is a function of u. So there are two functions there. So that is what we do if you want to find this type of problem. So now let me use example to buttress my point. Example, find the derivative of each of the following. A, that is when you have 2x plus 5 raised to power 3. Then B, let's just take two examples where we have 3x minus 1 raised to power 7. So this is what I'm trying to say. That is, if you have a function y is equal to 2x plus 5 raised to power 3. In this case now, it's still a polynomial function. But this function has raised to power of something. In this case now, it's raised to power 3. In this case now, it's raised to power 7. If I want to differentiate this now, without the knowledge of function or chain rule, what I would need to do is I'll first expand everything. Before I will now differentiate one after the other. But in order not to stress myself, if I understand the concept of function, I can just go ahead and do this directly. Then what am I going to do? I will say let u to be equal to 2x plus 5. That is, I will represent the core. What I have inside the bracket is called the core. So I will represent this one is called the core. So I will represent the core by u. Then let u equal to 2x plus 5. So that I'm going to differentiate u with respect to x. Du dx will now give me 2. Differentiation of a constant is 0. Then what do I have left here? This will now be y will now be equal to u raised power 3, because I've represented everything inside the bracket as u. So that I will now find the y du. I'm differentiating u with y with respect to u here. So that will now give me 3 can come down. I have 3 u squared, because if you want to differentiate, the power will come down, then I'll subtract 1 from the power. This is what I'm going to get. But we are asked to differentiate y with respect to x, not with respect to u. So therefore, the y dx will now be equal to dy du multiplied by du dx. Since I cannot differentiate directly, I decided to use the light statement. Then I record. So at the end of the day, what is dy du? Dy du is 3u squared multiplied by du dx. Du dx is 2. Du dx is 2 multiplied by 2. At the end of the day, I have 3 times 2, 6u squared. Then what is 6? 6. We are given the function in the form of x, not u. So I will recall u is given as what? 2x plus 5. So I'm going to have 6 into bracket 2x plus 5 all squared. And that will be the value of my dy dx. So when we have this question in this form, maybe raise the power of n, then we are expected to use function of function or chain rule to be able to differentiate such problem. So we do the second one. We are going to do the second one. The second one, y is given as 3x minus 1, everything raised to power 7. So we say let u equal to 3x minus 1. Du dx will be 3. The variation of constant is 0. Then y is given as u raised to power 7. So we find the y du to be 7u raised to power 6. That is, the power will come down, we subtract 1 from the power. Therefore, the y dx will now be what? The y du multiplied by du dx. So dy du is 7u raised to power 6 multiplied by du dx is 3. That is 3. So we are going to have 3 times 7, 21u raised to power 6. Then what is the value of u? U is 3x minus 1. So I'm going to have 21 into bracket 3x minus 1, everything raised to power 6. And that will be the value of the y dx. So we take another example. Let's take another example before we call it today. So the second example. So let's see. We have to find the derivative of, in this case, we have y is equal to square root of 4x minus 3. Then let's take this last one. Then we have y to be equal to 2 all over square root of 2x squared minus 4x plus 9. That's what we're going to get. So whenever we are given a polynomial, any function, either polynomial, irrespective of the function, that has raised to power of something, then we should know that we are going to use function of a function to be able to solve such problem. We can't do it directly. Like in this case now, in this second example now. So how do we get the derivative? When we have raised to power half, a is equal to y is equal to square root of 4x minus 3. That's what we are given. So how do we solve this? Of course, raised to power simply means 4x minus 3, everything raised to power half. That is the interpretation. So we let u to be equal to u raised to power half. So dy du will now be equal to half will come down. I will have half u raised to power half minus 1 is minus half. That's what we get. Please let's look at it very well. That will be minus half. At the end of the day, the y, the x will now be equal to the y, the u multiplied by the u, the x, and that will be half u raised to power minus half multiplied by 4. Here 1, here 2. At the end of the day, we have 2u raised to power half. Then, of course, what is u? That will be 2. U is given as 4x minus 3. We have into bracket 4x minus 3. Everything raised to power minus half. That's what we are going to have. So we can just stop at that point, or I can decide to rewrite this. If I decide not to stop there, this is what I can do. I will just say I can decide to rewrite this as dy dx. No. Let me bring it here so that everything will be neater. So if I don't want to stop, you can stop at this point too. But if you don't want to stop at this point, we can go ahead and rewrite and say dy dx will now be equal to dy dx will now be equal to 2 all over 4x minus 3 raised to power half. So using the knowledge of indices, and that's same thing as 2 all over square root of 4x minus 3. So that will be the final answer for the first question. So we go ahead and solve the second one before we call it a day. So let's solve the second question. So this is the second question. So we solve the second question. Under example 2, the second question is we have b to be equal to y is equal to 2 all over square root of 2x squared minus 4x plus 9. That's what we are given. So this same thing as using 2 all over 2x squared minus 4x plus 9, everything raised by half. That's what we get. That is what we are going to get. So I can, and of course, I can also rewrite this. I can rewrite this also. I can try to bring this out, or let me just leave it this way. And if I don't want to do it that way, I can write this and say this is the same thing as 2 into bracket 2x squared minus 4x plus 9, everything raised by minus half. You know, law of indices. This is reciprocal, we can write it that way. So we now say let u to equal to 2x squared minus 4x plus 9. What I have in the bracket, inside the bracket is called core. We represent it as u. So that when we find du dx, you know, we are differentiating u with respect to s, will now be 2 times 2, 4x minus 4. Then y will now be equal to 2 u raised by minus half. We have represented everything inside the bracket as u. So if you now differentiate the y du, we are going to have minus half multiplied by 2, u raised by minus half minus 1, that will be minus 3 over 2. This will take care of this. At the end of the day, we are going to have minus u minus 3 over 2 as our dy du. Then at the end of the day, the y dx will now be the y du multiplied by the u dx. And that will be the y du is minus u minus 3 over 2 multiplied by the u dx is 4x minus 4. So if I decide to multiply here, I'm going to have minus into bracket 4x minus 4 u raised by minus 3 over 2. And this same thing as I can change this to 4 minus 4x. So I can do this. I can change this to 4 minus 4x into bracket u raised by, of course, this can come down all over. I will have u raised by 3 over 2. And this same thing as 4 minus 4x all over, what is u? U is the same thing as 2x squared minus 4x plus 9 raised by 3 over 2. And that's what we are going to get. That's the final answer. That will be the final answer for the question. So I would love to stop here because of our time. So if you have any further question on function of a function or chain rule, you can just type at the comment section. I promise to attend to every question raised at the comment section. So thank you for listening, and God bless.
Mathematics made easy, no more fear. Target online class, we got you. Wherever you want to from, we got what you need.